Hello and welcome to this video. In this video we're going to be talking about the various ways to deal with flipped triangles and what they are, where they come from, and how to correct them. To begin, we're going to take our mesh and we're going to go ahead and we're going to flatten some of the surfaces on this mesh. So I'm just going to rotate this around. I'm just going to flatten the top and bottom surfaces of the pig. We're not going to worry about the ears or the arms or the snout. So we're going to turn off our surface and mesh and model layer, and we're going to focus only on the top. We're going to minimize the perspective viewport, we're going to maximize the top viewport, and we're going to go back into shaded mode. Now we are looking at the surface of our mesh, and we're looking at the results of the initial flatten command. And the initial flatten command simply uses a projection pre-flattener to create the initial flat pattern by projecting it onto the pattern plane. Because of the curvature of these pieces, when we do the projection flattening, we end up with the pattern folding in under itself, and this is what flipped triangles are. So if we zoom in here, we can see how when the projection was flattened, we've got triangles that are both looking towards the camera and away from the camera. They folded in under themselves. And in terms of the pattern, this is going to create a fold or wrinkle in the pattern, and this is what is known as a flipped triangle. So if we were to try to cut out this pattern, our pattern would be way too small. Usually when we have folds or wrinkles, it's an indication that we've lost material of the pattern. So these are patterning errors that need to be corrected. There are three primary ways to fix folds or wrinkles or flipped triangles. And in order of most usefulness, the first method is to simply run a different pre-flattener. So if we use if we flatten an object and the projection flattening fails, your next step would be to try fracture or pelt. And in the case of these pieces, if we try fracturing here, we can try a couple different spots. We're still seeing some folds and wrinkles or flipped triangles here. Fracture probably is not the best pre-flattener for this, although it looks like we've fixed them here. But if we move on to pelt, we can get a much better pattern just by pelting it. We've removed the folds or wrinkles or the flipped triangles. So in this case, the pelt pre-flattener, simply using another pre-flattener, has done a very good job of removing the flipped triangles. The second method is to use ExactFlat's automated flip triangle removal tool. And this method is not a pre-flattener, it is an additional tool, and it will try to manually manipulate the vertices to remove the folds and wrinkles from the pattern. So it works on pieces where the shape is very close to the final pattern piece. If you want to preserve the shape of the pattern, we can use the tool to try to remove the folds or wrinkles without modifying the shape of the piece. So we start the tool by clicking the icon here. We select a pattern piece to use the tool on, and then we press enter, and it's going to run. And in this case, it was unable to remove any of the folds or wrinkles or flip triangles, and this is due to limitations of the algorithm. It works best on pieces with a smaller number of flip triangles. So in this case, for this piece here, it failed to remove all the flip triangles, although it did fix some of them. So for this piece, we would go back to probably the pelt pre-flattener, and in this case, it's removed them all. The third method for removing flip triangles, folds, or wrinkles is to use manual vertex manipulation. So we start the vertex manipulator by clicking this icon here, and this tool allows us to grab individual vertices on the mesh and move them around. So in this case, I'm using the tool to artificially create a flip triangle, and we can see that we got the three inset triangles here. So just as I did to create the flip triangle, if we click on the point here, drag some of these triangles out of the way, we can use the vertex manipulator to manually manipulate the vertices to remove the folds or wrinkles. So this tool is probably the most difficult method for removing flip triangles, and that's simply because it's hard to select the correct vertex, especially if we're in an area that has a lot of a very high triangle count. It's difficult to select the correct triangle. It may also be difficult to figure out where the vertex needs to be placed. So it's the most difficult method to use, but it is another method that can be used to correct flip triangles. Lastly, if we have a mesh, I'm going to try to create a bad mesh using the fracture tool here. If we've got a mesh that none of the tools are working to try to remove the flip triangles or the folds or wrinkles, what we can do, we'll use this one as an example over here. We can see we've got some flip triangles right here. We can use the exact flat cutting tools to cut out, whoops, I just accidentally fractured that. So I'm just going to fracture this again. So we've got our flip triangles back over here. We can use the exact flat cutting tools to remove a piece of the mesh. So I'm going to create two cuts here. I'll cut out the corner. And now that we've reduced the complexity of the mesh that has the flip triangles, we've essentially subdivided this mesh, and this is going to allow us to use any of our previous three methods to remove the flip triangles from a much smaller portion of the mesh. This also works well if you want to preserve the shape of the mesh. You can simply cut out the flip triangles, fix the flip triangles, and then you can delete the cuts. So I could use any of the methods now to remove these flip triangles, such as a pre-flattener, or in this case I'm going to use the flip triangle removal tool, and very quickly it's removed our flip triangles for us. And now I can use the exact flat cutting tools to remove this cut. So I'm just going to delete the cut along here and here, and I've removed the flip triangles. Sometimes it's difficult to spot the flip triangles. So one way to deal with this is we can switch over to the highlights tab, and we can turn off the strain highlight, and we can also turn off the edge tessellation, and this is going to allow us to very easily see any kind of flip triangle. So for this piece right here, by not having the strain highlight turned on and by not having the edge highlights turned on, we can easily see that we have the inset triangles and we've got the hatch marks associated with our flip triangles. So using this, we can go back to fracture. In this case, we were able to fracture it first try and create a pattern without flip triangles, folds, or wrinkles. So we've got a good pattern again now. And when we're done, we can turn the edge highlight back on, we can turn the strain highlight back on. So to summarize, there are three main ways to remove folds or wrinkles or flip triangles from your pattern piece. The first method is to simply use a different pre-flattener to create a new initial unoptimized flat pattern. This is probably the most efficient and best method for removing a fold or wrinkle. If the shape of your pattern piece is very important and you can't or you don't want to use a pre-flattener, then you can use the automated flip triangle removal tool. It will attempt to remove flip triangles without altering the shape of the pattern piece. And lastly, the third method is to do manual vertex manipulation, and this allows you to manually drag vertices of triangles to change the orientation of the triangle. And you can use a combination of all these three methods with the divide and conquer by subdividing your mesh to make it easier to use some of these tools. And again, this helps with preserving the shape of the pattern. Thank you for watching.